All right, this is notes 2.8, absolute value functions and their graphs. So a function in the form of f of x equals absolute value of mx plus b, close the absolute value plus c, where m does not equal 0 is an absolute value function. The line that divides the figure into two parts that are mirror images is called the axis of symmetry. A point where the function reaches a maximum or a minimum value is the vertex. All right, so in the last lesson, you guys should have learned about transformations. So now we're going to apply our transformations to an actual function. So I actually prefer for you guys to use transformations when graphing a function. We will continue to use transformations for the entire school year. So it's best for you guys just to start understanding them now and memorizing them or knowing what to do, because it's not going to go away. So with every function, we have a parent function. So that means the most basic it can possibly be. So it's the parent function. It's not stretched. It's not shifted. It's not moved right or left. It's not reflected. Nothing like that. Okay, so for the absolute value function, our most basic function is just y equals absolute value of x. This is called the parent function. We're going to go ahead and graph the parent function, and it's best if you guys just memorize what this graph looks like, know where the points go, and then when we start applying transformations, it's going to be fairly simple for you guys. All right, so worst comes to worst, you haven't memorized your transformations. You can always make a t-chart when graphing any sort of function. So remember, a t-chart is this thing right here. And that is, you just pick values of x, you plug it into the function, get the output, which is your y value. So let's go ahead and do this one. -3. So if I do the absolute value, so if I plug in -3 right here, if I do the absolute value of that, I would get +3. If I did -2, absolute value of -2 is +2. Absolute value of -1 would be +1. 0, the absolute value of 0 is 0. Absolute value of 1, sometimes we kind of get confused and we just think absolute value means the opposite sign. That's not what it means. Absolute value just means it's always positive because it's a distance. So the absolute value of 1 is just 1. Absolute value of 2 is 2. Absolute value of 3 is 3. All right, so looking at these y values, I can see where my minimum is. What's the lowest it goes? And if you guys notice that 0, 0 is going to be the lowest, because on either side, then it starts going up. So this side from 0 is going up, and this side's also going up. So 0, 0 would be my vertex. Okay, also at 0, we have symmetry. So if we see on each side of the 0, there's 1, and then there's a 2, and then there's a 3, and if you guys would assume the pattern, then 4, then 5, so on and so forth. All right, so this graph is going to be a V. It looks just like a V with a hard point of V, just like the letter V. All right, so let's go ahead and graph these points. So we have 0, 0, 1, 1, 2, 2, 3, 3, and then it would go 4, 4, 5, 5, so on and so forth. Other side, -1, 1, -2, 2, -3, 3. So this is what our graph looks like. So we can see at 0, 0, it's the minimum, it's the vertex of our graph. And then if I drew, or if you use your imagination, if you folded this piece of paper right on that y-axis, you would have symmetry. So there is symmetry at x equals 0. All right, let's go ahead and connect our dots. And make sure we put arrows on both ends, because this does continue in both directions forever and ever and ever. Okay, so this is the parent graph. It will look like this every single time. If it's y equals absolute value of x, this is the graph. Know that it looks like a V. You should know it looks like a B. Okay, so now we're going to move on. And we have this guy. We actually love this form. And the reason we love this form is this form shows transformations. I think and I believe transformations are the quickest and easiest way to graph any sort of graph. So you know the parent function and then you just transform it. And this format gives me that transformations, shows me the transformations. So we'll go through these transformations. I will be using a lot of the same terminology. I talk about inside, outside. So let's just kind of go through what I talk about so you're not confused ever. So if you guys look at this function's an absolute value function. So when I'm talking about inside the function, that means inside the absolute values. If I talk about outside the function, that means on the outside of those absolute values. Okay, so inside the function, so this is absolute value, so inside absolute value, on the outside of the absolute values. Okay, another thing I'm always going to say is, on the outside is the same as what you think. Outside, same as what you think. Inside, opposite of what you think. Outside is all vertical transformations, and then the inside is all horizontal transformations. And I will literally repeat this 5 million times, so you should start understanding it and getting the hang of it, but this will not go away. We'll do this with every function that we see in this class. We will do transformations. All right, so let's talk about this. So A is on the outside of the function. Outside of the function is vertical. Outside of the function is the same as what we think. This guy is being multiplied to it. So when something's being multiplied to your function, it's going to create a stretch or a shrink. So this one, since it's on the outside, this is vertical. And this could be a stretch or a shrink. And this is the factor, whatever it is. All right, so outside, vertical, outside, same as what you think. So let's talk about what I mean, same as what you think. So let's pretend this number is 2. Same as what I would think is I would think 2 would stretch something. If I multiplied by something by 2, it's getting bigger, it's getting stretched. So 2, 3, 4, 5, all of those things would stretch my graph vertically. Okay, now let's think about how would something shrink? How would I make it smaller? So shrink, it's going to be the same as what you think, so that's going to be in between 0 and 1. So we're talking about a half, a fourth, a third, 2/5. If it's in between 0 and 1, that's going to give you your shrink. Okay, hopefully that makes sense. So again, when it's on the outside, same as what you think. Stretch would be 2, 3, 4, 5, 5 halves, because that's bigger than 1. Anything bigger than 1. Shrink is going to be between 0 and 1. All right, so now we have HK. So HK is really nice, and we're going to continue to use H and K, these same, what are those called, variables. We're going to keep using them the same for all of our transformations. So we'll continue to use H, we'll continue to use K, we continue to use A. All of these will remain the same for each function. So the beautiful thing about this HK gives you your vertex. Okay, let's notice this though. In this formula, it's minus H, but we say just H, the opposite. K stays the same. So this comes into play with anything on the inside is opposite of what you think. I think it's negative, but it's really positive. Outside, same as what you think. So it's a positive, stays a positive. Okay, these also give you your vertical and horizontal shifts. So let's talk about it. H gives you your horizontal because it's on the inside. Everything on the inside is horizontal. So this is going to be a horizontal shift. And then K will be a vertical shift. Okay, so like I always say, so on the inside, horizontal, inside opposite of what you think. So like if this was minus 2, in my head I'm going minus 2 must be left 2. but it's opposite of what you think. So minus 2 is really right 2. If this said plus 3, that's really left 3, opposite of what I want to think. K is on the outside. It's the same as what you think. If it's plus 2, up 2. Minus 3, down 3. All right, last one here is x equals h. X equals h means that's going to be the vertical line at your vertex. And that vertical line at your vertex would be your axis of symmetry. All right, and if that was a lot to take in, don't worry, we will continue to talk about it over and over and over. You guys will get the hang of it. All right, so let's talk about this. If you guys notice on the second one, yours does not look like that. You need to scribble out the negative that was right here and then put a minus k. So make it look like mine. Okay, so the first one's talking about vertical transformations. So again, it's a vertical because it's on the outside of the absolute value, and then it's going to be the same as what we think because everything on the outside, same as what we think. So a plus k is going to be up k units. And if we had a minus k, that means it's going to go down k units. Perfect. Next page. All right, now we're going to talk about our horizontal. So this is everything on the inside of the absolute values is going to be horizontal. And it's going to be the opposite of what I think. So inside, opposite of what I think, inside, horizontal. So minus h, I'm thinking left, right? Minus would go left, but really it's the opposite. So a minus h is going to go right h units, and a plus would go left h units. All right, vertical, stretch, and shrink. It's on the outside, so that's why it's vertical. We do horizontal stretches and shrinks. They're just not as common, but we will talk about those, just not as much as the vertical. The vertical is the main one. So we have a vertical stretch or shrink, or a stretch and a compression. So, like we were saying, if we wanted this thing to stretch, we would want to multiply it by something bigger than 1. So if a is bigger than 1, we would have a stretch. And if we wanted to shrink it or compress it, a would have to be between 0 and 1. So again, I think fractions, just be careful, your fraction still has to be between 0 and 1. Half, third, 2/3, a fourth, a fifth, 1/10, whatever the case is. Okay, so if a is between 0 and 1, that would be a shrink. If a is 1, there's no stretch or shrink. It's just normal. No stretches, no shrinks, just the normal parent. Okay, next one, reflections. So again, reflections, this one is on the outside. Okay, this can sometimes be a little bit harder to think about, but I think you guys will understand. Okay, so it's on the outside. So I said everything on the outside is vertical. It has a vertical transformation. So if I had a V that looks like this, and it's going to do a vertical reflection, that means it's going to go this way. So this is vertical versus this would be horizontally. Okay, so vertical. So when this is happening, it's actually reflecting across your x-axis. Okay, and then this one's on the inside. Everything on the inside is horizontally, so this is going to flip horizontally. So that's going to go across your y-axis. Perfect. All right, let's go ahead and scroll down. So we're going to talk about this first graph and how it's different than my parent graph. So again, we're using transformations. All right, so parent graph, as you guys recall, is just y equals absolute value of x. So we want to know what is different, what has happened to this parent function graph. Hopefully you guys are identifying, well, I added 2 to the end of it. So what's different is this plus 2. Well, what is that plus 2 going to do to our graph? Okay, hopefully you guys are already getting the hang of this. It's on the outside. Everything on the outside is vertical. Everything on the outside is the same as what I think. If it's being added or subtracted, it's a shift, right, left, up, down. Since this is vertical, this is an up or down, and since it's positive, this is an up. So this is going to go shift up 2. So all my parent graph is going to do is just shift up 2. That's it. Super simple. So again, you guys should know what your parent graph is. I'm just going to put dots for my parent graph. So remember, it's this V that goes perfectly kitty corner. Okay, so that green one is my parent graph. And all I'm going to do with all of these points is I'm just going to take each point and I'm just going to shift them all up 2. So this one up 2, here, and here, and here, and here. Okay, so each one of my points shifted up 2, up 2, up 2, up 2, and that's my new graph. Let's go ahead and connect that. And that would be my new graph. Let's go ahead and state where my new vertex is. So my vertex is now at 0, 2. It went up 2. All right, we need to start practicing our domain and range. We do a lot of domain and range, so we're going to practice. Okay, domain is your x values. So domain is your x values. And I always say right and left. You need, or left to right, actually. So domain is my x values, so we're talking about everything this way. Range is your y values, so everything that way. Again, you start at the left side, go to the right, start at the bottom, go to the top. All right, so let's talk about this one. Looking at my domain. So remember, this thing is going to keep getting wider and wider forever and ever and ever and ever. So we look at our x's. We go from the left side. So coming from this left side, where is that graph going to come from? Or in other words, is there any values of x that aren't going to work? Would negative 100 work? Could you plug negative 100 in? Sure. You could plug in negative 1,000. You could plug in anything. So it's going to come from negative infinity, which is over here. So this is coming from negative infinity, and it's going to continue to positive infinity because this v just keeps going on wider and wider and wider and wider forever and ever and ever. So it's going to cover your whole x-axis. So this is going to be from negative infinity to positive infinity. Okay, something we need to talk about, parentheses versus brackets. I don't know if you guys ever, I'm assuming you learned interval notation. This is called interval notation. So infinity has to have parentheses. Parentheses means does not include. Well, we can't include infinity because infinity is not like a finite number that I can include. Infinity keeps going forever and ever and ever, so I can never bound it. I can never say, yes, include infinity, because I know what infinity is. Like, we don't know what that is, so it can't be bounded, in other words. Okay, so it goes from negative infinity to positive infinity. Infinities always have a parenthesis on it. Always. It is not included. Okay, now let's talk about our range, though. So range, I like to go bottom to top, so you're looking at your y values. So if we're looking down here, there's nothing. There's no part of my graph that's down here. Nothing, 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 until I get to this minimum. Now my range starts. So what is your y value here? My y value here is going to be 2. So your range is starting at 2, and then this is going to keep increasing and go up forever and ever and ever. So since it's going to keep going up towards the sky, then it's going to go towards infinity. So 2, so this is going 2 to infinity. All right, so 2 to infinity. Infinity cannot be included. But is 2 included? Is 2 part of this graph? Is 2 a closed dot? Is it part of the graph? Well, yes, it is. So we use a bracket. Bracket means include 2. Include 2. All right, hopefully that little lesson on domain and range sparks some memories for you guys. All right, let's go ahead and do this bottom one. So again, we're going to describe how this one is different from my parent graph. So there's 2 things that are new on this one. I have a -2 in here and a +1 on the outside. They're both being added or subtracted, which tells me it's a shift. So they're both shifts. We just need to know which way do they shift ultimately. So let's go ahead and talk about that. Let's talk about this -2 first. -2, inside. Inside's opposite of what you think. Inside is horizontal. So I'm thinking that this is left 2, but really this is right 2. So this is going to go shift right 2. And then this guy, this +1 on the outside is vertical, so that's ups, downs, same as what you think. So this is going to go up 1. So again, we can take that parent function and then we can just take all the points and go right 2, up 1. Or an easier way, because we already know the pattern of this of these absolute values and there's no stretches or shrinks. So, or we could just jump right to it. I know I'm going to go right 2, up 1. This is my new vertex, and then you guys should know the vertex is the V from, or you should know the points, you should know the pattern, because it's going to be a V, and it goes up. Each side is going up like by a slope of 1, up 1 over 1, up 1 over 1, up 1 over 1. All right, let's go ahead and connect this. Okay, and that's what my graph will look like. So my vertex is at 2, 1. Let's go ahead and state our domain and range. So we'll go domain. So again, domain is your x values. It goes left, right. Starting from the left. Again, this is getting wider and wider and wider, so it's going to ultimately cover the entire x-axis. So this is going to start from -infinity, and it's going to travel to +infinity. So -infinity to +infinity. Again, we need to make sure that we have parentheses, not brackets. Infinity is not included. Range. Bottom to top. Start at the bottom. There's no part of my graph, no part of my graph, no part of my graph, no part of my graph until I get to y is 1. Then my graph starts, and then it will continue in an upwards direction forever. So it's going to start at 1, go towards infinity. 1 is included. It is part of the graph. We have a solid closed dot there. It's included. All right, next page. All right, so this one said, oh, now we're talking about vertical stretches and compressions. So I will teach you guys how I do those. So this graph, y equals 2 absolute value of x. So what is that 2 on the outside going to do to my graph? Well, this 2 on the outside is going to be it's on the outside, so same as what you think, it's being multiplied. So this is going to stretch my graph by 2. It's vertically stretching my graph by 2. So this is going to be a vertical stretch by 2. All right, so I will go ahead and show you guys how I vertically stretch, just so we have an idea, and then I'll give you another way to think about it as well. Okay, so again, we should know our parent. So I'm just going to do my parent. I'm going to make dots in green. Okay, that's my parent. Each side is like going up by a slope of 1. So it looks like that. Vertex 0, 0. All right. So now I'm vertically stretching by 2. So that means I'm taking the y distance, because y is vertical. I'm taking the y distance and I'm going to double it. So if you guys look at this one, this y distance to my x-axis is a distance of 1. So instead of a distance of 1, I'm now going to go a distance of 2. So I'm doubling that y distance, that vertical distance. Okay, if you move over 1, this has a distance of 2, so I'm going to double that and go to 4. Okay, next one. This one has a distance of 3. I'm going to double that and go to 6. So I am taking my vertical distances and doubling them. Okay, same with the other side. And now I should have a steeper, I should have a stretched out V, so it should have got taller and skinnier, which it did. So let's go ahead and connect those dots. Like so. Okay, so those green dots were my my parent, and then the red dots were my new one with the stretch. Another way to think about this one, but really you can only think about this on lines or this absolute value function, so I don't use this often because it doesn't apply to all of my functions, is you guys can think of this stretch as the slope, quote unquote. It's not really a slope, but it's just a way to think about it. So a equals 2 acts like a slope, quote unquote. It's not really a slope because this isn't a line, but it's 2 lines put together ultimately, with my vertex at 0, 0. Okay, so what that's saying, it has a slope. So rise over run, so it's saying up 2 over 1, and that's what happened from 0, 0. Up 2 over 1, up 2 over 1, up 2 over 1. Okay, same with the other direction, up 2 over 1, up 2 over 1, up 2 over 1. So that's another way to think about these. Alright, this next one is a good one because we actually haven't talked about this yet. Is there's a negative out front. So you guys always get, in my class, kids always get this wrong for me. So I will ask, what's the stretch or shrink? And you're going to tell me it's negative 2/3. Well, please tell me how I stretch or shrink something by a negative distance. That doesn't make sense. The negative is ignored. The negative is ignored. The negative tells you the reflection. Okay, so if I ask you, is this stretch or shrink, you should tell me this is shrunk, and you should tell me by 2/3, not negative 2/3, by positive 2/3, because I can shrink something by a positive distance, I can stretch something by a positive distance, but I can't do that with a negative distance. Because there's no such thing as negative distance, if that makes sense. Okay, so let's talk about this. Okay, a reflection on the outside. This is going to be the most common one you see in my class, reflections on the outside. Reflections on the outside, everything on the outside is vertical, so it's going to reflect vertically, or it's going to reflect across the x-axis. Okay, so this guy has a reflection across x-axis. And then this 2/3 is going to be a vertical shrink. It's less than 1. Oh, that was ugly. By positive 2/3. By a positive 2/3. All right. This one's a little more strange, but I'm going to show you how to do it with a transformation, and then we'll confirm it with the slope idea. Okay, so again, my parent graph. We should just have this memorized. We should know what it looks like the back of our hands. Okay, so there's my parent. First thing I'm going to do is I'm going to go ahead and reflect it across X. So now it's going to be going... mouse. So now it's going to be going in a downward direction. Still at 0, 0 though. Okay, like so. All right, so now what we're going to do is we're going to shrink all of these distances by 2/3. Okay, it's weird, okay? If I went ahead and I did this one by 2/3, it would be like right there. If I did this one by 2/3, it would be like right in here somewhere. So let's just find the easy ones that are going to give me a nice spot. So which numbers could I multiply by 2 and then be able to divide it by 3? Okay, like what x values could I multiply by 2 and then divide by 3? Hopefully you guys are thinking 3. So if I multiply this 3 by 2, I get 6, and then I'm going to divide it by 3 and get 2. Hopefully you guys all followed that. -3 is going to do the same thing, and I would get -2. Sorry, -2, not +2. Okay, the next nice one would be 6. 6 is way over here, but we could do it. 6 times 2 is 12, and then 12 divided by, just kidding, that won't fit. 2, 12, 4, no, we could do it, 4. We have enough space. Sorry, I wasn't sure if we had enough space. We do. Okay, so again, I did 6. So what I'm doing is I'm just taking that distance of 6, multiplying it by 2 to get 12, dividing it by 3 to get 4. So right here. So my final points would be these red points. So let's go ahead and connect those. So it would be there and there. Okay, let's just confirm this with the idea that slope idea. So if we confirm this, so we did -2/3, right? So that means we're going down to left or right 3. Is that what happened from here? I went down to right 3, I went down to left 3, so we can still use that same idea. My vertex is still at 0, 0 because I did not shift right, left, up, down. So vertex 0, 0. Okay, so hopefully you guys understand taking those y distances and then doing whatever the stretch or shrink is to it. That's how we're going to do it for our functions in the future as well. Alright, this one's fun. We have a lot of different things that are happening to this. So we're just going to go through it one by one, and you guys are going to tell me what's going to happen to it. So the first thing I notice, okay, we'll do the vertex first. Vertex, HK. This is your H, this is your K value. H is opposite of what you think, K is the same. So this would be 1, -3. Your axis of symmetry is where, I shouldn't have an equals yet. Your axis of symmetry is the vertical line through your x point, or your x value of your vertex. So that would be at x equals 1. All right, now let's go ahead and talk about our transformations. We're just going to go in order. First things first, I have a negative out front. Negative out front, reflection. This is a reflection across the x-axis. So first thing, we have a reflection across x. Okay, now we evaluate the 2. So remember the negative and the 2 are separate things. Negative's reflection, this 2 is being multiplied to my function, so that's going to be it's on the outside, vertical, and then that's going to be a stretch because it's bigger than 2. So I have a vertical stretch by 2. Okay, next, we have a -1. When we're adding or subtracting something, it's a shift. Inside is horizontal, inside's opposite of what you think, so this is actually a shift right 1. And last but not least, we have this minus 3 on the outside. Outside is vertical. Outside's the same as what you think. So this is a shift down 3. All right. With all of this information, I could go ahead and graph this. So I'm going to do this all in one step, so hopefully you guys understand. So I'm going to start with my vertex. I'm at 1, -3. Okay, instead of this being a right side up V, this is going to be an upside down V because it was reflected. And then it was stretched by 2. So normally I go down 1 over 1, but now I'm going to go down 2 over 1 to give it that stretch. And then we just follow the pattern, get my other spots, and that's going to be what it looks like. Connect it. And my graph would look like so. All right, something a little bit different to think about here. This one, it gives us the graph, and we have to figure out, well, what's the equation to this graph? Okay, so first things first, find your vertex. Oops. So let's go ahead and find our vertex. So our vertex is at -1, +4. Okay, and then we want to find our A value or our stretch or our shrink. So hopefully you guys can tell that this guy right here normally goes over 1, down 1, over 2, down 2, or, sorry, over 1, down 1, over 1, down 1, over 1, down 1. Okay, but this guy is going over 1, down 2, over 1, down 2, so this one was stretched by 2. So your A value is 2. All right, so with this information, we can say what the equation was. So remember, your vertex, this is giving you your H, and this is giving your K. So we have our H, our K, we have our A. So we're to a point where we just plug in the stuff and we get our equation. So remember, the equation goes y equals A, absolute value, x minus h plus k. Plug it all in. Get y equals 2 x minus h, so it's going to be opposite, plus 1 plus 4. The last thing that we have to account for that hopefully you guys realized is this thing was reflected. It's an upside down V, so that means there is a negative out front. And that would be our equation. Okay, you guys should pause the video here and then try this next one and see if you guys can figure out the equation on this next one. Alright, so for this guy, vertex is at 1, 0. A value, hopefully you guys were able to figure out your A value. This one is going over 1, up a half, over 1, up a half, over 1, up a half. It was squished, which means it was shrunk. So my A value is 1/2. All right, plug it all in. I'd get y equals A is a half. X minus h, x minus 1, plus k, which is 0. Do not put plus 0. This one is positive because this is still a positive V. Alrighty, last page. Can I move myself here? There we go. Alright, last page. Okay, so this one's really important. This is the first time we're going to talk about a horizontal stretch shrink. We've only done vertical. This one's going to give us a horizontal. And there's some things that we have to be really careful about when it comes to horizontal ones. So we're going to go through this carefully and slowly. So let's go ahead and do the first one. The first one is not new. We've been doing ones like this. You guys should be able to handle the first one. So we're going to get y equals 2x plus 1 absolute value. Okay, let's just talk about the transformations on this guy. So transformations. This 2 would be a vertical stretch by 2. Plus 1 on the inside is your horizontal shift, and it's opposite of what you think. So that one's going to go left 1. Let's go ahead and graph this guy. I'll graph this one in red. So we can go ahead, graph it. So everything just shifted left 1. So now my vertex is here at -1, 0. Okay, it's stretched by 2, so instead of over 1, up 1, I'm going over 1, up 2. That vertical distance is doubled. So over 1, up 2, over 1, up 2, over 1, up 2. Do the pattern on the other side. Okay, and then let's go ahead and connect this. So it's going to look like this. All right, so that's the first one, nothing new. That's what we've gone over this whole lesson. Next one though. Let's change the color here. Y equals absolute value of 2x plus 1. Struggling. Okay. Y equals 2x plus 1. The 2 is now inside the function. 2 is being multiplied to the inside. So it's no longer a vertical stretch or shrink. It's a horizontal stretch or shrink. Okay? The biggest mistake that you guys are going to make is that this 2 has to be factored out of everything on the inside to see the true transformations. And that's where we all make mistakes. I forget it sometimes. We're all going to do it. So let's be really careful. So whenever there's something being multiplied to your x on the inside, it must be factored out. It must be. So that's what we're going to go ahead and do first. So I'm going to get y equals absolute value. I'm factoring out the 2, so there has to be a 1 on the x. So when I factor out this 2, I get an x plus, and remember when we're factoring something out, we're dividing something out, so I'm really doing 1 divided by 2, which would give me 1/2. This form, you can now see your true transformations. All right, so let's talk about these guys. Scroll down a little bit. All right, so 2 is being multiplied to the inside. It is no longer vertical. It's now horizontal. Everything on the inside is horizontal. Everything on the inside is horizontal. So this is a horizontal. Okay. Also different. Remember, everything on the inside is opposite of what I think. So when I see 2, I assume it's a stretch. But it's actually opposite of what I think. So this is actually a shrink by 1/2. Opposite of what you think. All right, so like I've been saying the whole time, inside, opposite of what you think, inside, horizontal. So this is horizontal. This is a shrink by 1/2. It's a shrink by 1/2. If that had been at 1/2 instead of the 2, then this would be a stretch by 2, horizontally, opposites. And then again, this plus 1/2 is actually going to go the opposite direction, so this is really a left by 1/2. All right, so let's go ahead and graph this. So my vertex is moving over 1/2. So I'm literally right here. These are going to be very close to each other, so try to draw as straight as you can. Okay, so this is a horizontal shrink by a half. So normally I go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. Okay, well, instead of going over 1, I need to go over half that. So now it's going over a half, up 1, over a half, up 1, over a half, up 1, so on and so forth. So let's go ahead and follow that pattern. So I'm going over a half, up 1, over a half, up 1, over a half, up 1, over a half, up 1. Okay, so there's that side. Other side, over a half, up 1, 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 over a half, up 1. All right, let's go ahead and connect these. All right, and then that's what the other one would look like. Okay, these are very similar, and this is why it can get really confusing, is that horizontal shrink by a half acts like a vertical stretch by 2. Okay, and we're going to see that a lot because that's what's happening is I'm taking everything by a half. Well, when I put it on like perfect, what are those called? Like perfect crossing points on the graph. Okay, so the same thing is happening. So I'm going over a half, up 1. Well, that's the same thing as going over 1, up 2. So they act the same. The biggest difference, though, is this whole problem with factoring out this 2 and then getting the true transformation on the shift. All right, and I think that's all for this page. Yes, it is. Okay, so that was notes 2.8. I hope you guys have a great rest of your guys' day.